3-level system. I mean, they will give you the problem that will be based on 3-level system. So we'll discuss about that rate equation for 3 levels system. Okay. 3 levels. Okay. Let us assume this is your ground state level. Okay. Then you have a upper state and you have a metastable state. At ground state, that is Ng. At upper state, that is N of U. And for metastable state, it is N of mu. And again, I'll define the WP. Okay, so pumping rate. It means atom will be pumped from ground to, कैसे pump होता है? 3 level में काम करता है. Atom will be pumped from ground to upper with rate WP, and this rate will be same as downward also. Also, atom will jump from upper to metastable state. And let us assume the lifetime of this decay from upper to metastable state, let us assume this is tau of um. Tau comma tau subscript u comma m. So the lifetime of this decay from upper to metastable, that lifetime is how much? Tau u comma m. Okay. And lifetime of this decay from metastable to ground state. Okay. That lifetime, let us assume tau of m comma what? It should be g, right? So tau m g क्या रिप्रेजेंट कर रहा है कि मेटास्टेबल से ग्राउंड स्टेट में जो ट्रांजिशन हो रहा है उसका लाइफ टाइम टाउ. अपर से मेटा में जो डीके हो रहा है उसका लाइफ टाइम क्या है? अपर टू मेटास्टेबल स्टेट. सो यू कैन अंडरस्टैंड दैट सिंबल. यूएम का मतलब क्या है? अपर से मेटास्टेबल में जो ट्रांजिशन हो रहा है उसका लाइफ टाइम है. मेटा से ग्राउंड उसका लाइफ टाइम. So can you please tell me that total rate of change of population? Change of population of ground state. Okay. So total rate of change of ground state, it will be how much? dNg by dt. Total rate of change of population. So this process of pumping will decrease that population of ground state. So what I can write, that should be equals to WP Ng. This process will increase that population. This from upper to ground state, this process will increase that population. So I'll use that symbol plus. At what rate? That will be WP into N of U. Yesterday we have discussed. Also this process, decay from metastable state to ground state, this process again will increase that population of ground state. At what rate? That will be how much? That will be simply Nm divided by a lifetime of decay. So this representing total rate of change of population of ground state. So this pumping will decrease that population. This jumping will increase that population from upper to ground. Also, that decay from metastable to ground state. At what rate? At this rate, it will increase that population of ground state. So this is the total rate of change of population of ground state. Is this clear?
Yes, sir. Yes, sir.
Okay, so this is not equation 2, actually it will be 1, right? The first equation. Similarly, I can write that rate of change of population of metastable state dnm by dt. So this process, the decay from upper to metastable, that will increase that population of metastable state. At what rate? That will be nu by tau um. Decay from upper to metastable state, that will increase that population of metastable state at what rate? Nu by tau um. And decay from metastable state to ground state, decay from metastable state to ground state, that will decrease that population of metastable state. So at what rate? So since this is decreasing, I'll use minus sign. At what rate? That will be nm by lifetime of this decay, that will be tau of mg. So this representing total rate of change of population of metastable state. So this decay increasing that population at what rate? In this rate. This decay will decrease that population of metastable state at what rate? In this rate. Tell me if you have any doubt. So I'll use, this is your equation number 2. Then for that rate of change of population of upper state, that will be del dnu by dt. Okay. So that pumping of atoms from ground state to upper state, that will increase that population at what rate? Pumping of atom from ground state to upper state will increase that population of upper state. So I'll use plus sign. At what rate? That will be Wp into Ng. Decay of atoms from upper state to ground state will decrease that population of upper state. I'll use minus sign. At what rate that decay will be happen? Wp into Nu. Also, decay from upper to metastable state, again it will increase, again it will decrease that population of upper state. I'll use minus sign. At what rate? That will be Nu by tau of um. Right? So I'll use, this is your equation number 3. Tell me if you have any doubt. Yes. Is there any doubt?
No, sir.
Okay. Now, at thermal equilibrium, what will happen? So in thermal equilibrium, that rate of change of population of all state, that will be 0. So what I can write, dng by dt equals to dnm by dt equals to dnu by dt. That should be equals to 0. So rate of change of population of all state will be 0. When at equilibrium condition. Okay.
So why we are using the word thermal here?
Thermal means temperature of your system is constant.
Oh, means constant temperature here in the system.
Now, from equation 3, since at equilibrium dnu by dt equals to 0, so that I can write right hand term should be equal to 0. From equation 3, I must say at equilibrium, these three terms will be, sum of these three terms will be 0. Now, if I bring second term and third term on the right hand side, then how much I'll get? On the left hand side, WP NG will be left. Okay. एंड राइट हैंड साइड हम कौन सा टर्म लेके जा रहे हैं? ये वाला और ये वाला. तो दोनों प्लस आ जाएंगे और दोनों में क्या कॉमन है? ए न्यू कॉमन है. सो इनसाइड ब्रैकेट क्या मिलेगा आपको? यू विल हैव WP, देन फ्रॉम दैट लास्ट टर्म यू विल हैव ऑन बाय टाउ UM, ऑन बाय टाउ UM. Right? So from here I'll get that population of level U or population of upper level, that will be how much? It will be WP NG tau of UM divided by on plus WP tau of UM. So this is the population of upper level at thermal equilibrium. Okay. Now equation number 2. Again at thermal equilibrium, this should be 0. It means number of population NM at metastable, that will be how much? That will be tau of mg divided by tau of UM into N of U. Right? Now just we have obtained that value of N of U. I'll substitute here. I'll get the value of population of metastable state. So NM will be how much? It will be tau of mg divided by tau of UM, and then you have NU कितना आया था आपका? If you remember, it was nothing but WP NG tau of UM divided by 1 plus WP tau of UM. So just this tau of UM will be cancelled, and I'll get that population of metastable state, that will be WP NG then tau of mg divided by 1 plus WP tau of UM. Okay. This is the population of metastable state at thermal equilibrium. Tell me if you have any doubt.
No doubt, sir.
let us solve a problem based on rate equation. So this is the problem based on 3-level system, but this 3-level is of nitrogen laser. Okay, so this is a problem. Okay, so they have given the energy level diagram of nitrogen laser. Okay, so this level is ground state, first excited state, second excited state. Okay, initially all the atoms are at ground state, and atoms are basically pumped from ground state to second excited state at a rate of yes.
So we'll calculate this N U for sorry NG also, na? After this, we have to calculate.
We have calculated population of upper state, that is NU first. Then we have calculated that population of metastable state.
So for ground state also we'll calculate, or
We can actually we have calculated metastable state population in terms of ground state. अपर स्टेट का भी
Okay.
कैलकुलेट किया हम ग्राउंड स्टेट के रेस्पेक्ट पे. अगर टोटल पॉपुलेशन n है, then n I can write ng plus nm plus nu. Right. Now this ng you can calculate just by subtracting nm and nu. That is not important. Main thing that
okay,
important part is that population of metastable.
okay,
Okay,
sir.
because actually you are getting that laser light because of metastable state. Right? You have
Yes,
discussed
sir.
this thing.
Yes, sir.
So what I'm saying, you have a nitrogen level, nitrogen laser, and this is a 3-level laser. Initially, all the atoms at ground state, and atoms are pumping from ground state to second excited state at a rate, and that rate is given. That is 10 to the power 20 atoms per centimeter cube. Okay. Then these atoms from jump to first excited state, and lifetime of this decay is given tau 2 on, that is given as 20 nanosecond. Okay, and then atoms from first excited state decays to ground state. Okay, and lifetime of this decay again given tau on 0, that is on microsecond. Okay, so this diagram they have given that atoms are pumping to second excited state, and this atom can decay by only this chain. It can decay to on by this lifetime and then on to 0. So this diagram is given in the question, and they have asked how much will be the population of level 2, that is N2, also N1 at thermal equilibrium. So at thermal equilibrium, what will be the population of level 2, that is N2, and what will be the population of level on, that is N1. So at what condition? At thermal equilibrium. Okay. So let us solve this question. So let us assume that population at level 2, that is N2. So total rate of change of population will be how much? So pumping rate is how much? R. So this, at this rate, the population of level 2 is increasing. So I'll use plus sign. I'll use plus sign, but this decay from 2 to on, that will decrease that population of level 2. So I'll use minus sign. At what rate? That will be number of population at level 2 divided by a lifetime of this decay process. So that will be tau of 2 comma on. Okay, so this is the total rate of change of population of level 2. Okay, but they ask you to calculate that population at thermal equilibrium, right? At thermal equilibrium, total rate of change of population is how much? That should be 0.
Sir, R is pumping rate, na?
R is pumping rate. You can see, yes, pumping rate, yes. I mean per second में कितना atoms pump हो रहा है. Please don't confuse with this WP. हाँ, यहाँ पे R जो given है आपको, R का मतलब ये given है कि कितना पर सेकंड में कितना atoms यहाँ से level 2 में pump हो रहा है.
Same as that of WP, na? This is same, na?
No, it's not same. If we remember WP, we have defined WP was how much? If you remember, it was like B on 2 E of omega. So if you check its dimension, it will be different. It will be different. यहाँ पे जो आपको बोला गया है कि यहाँ पे पंपिंग, यहाँ पे इसका डायमेंशन क्या मिलेगा आपको WP का. If you calculate dimension, you will get second inverse. You will get second inverse. और यहाँ पे आपको जो बोला गया है कि पर सेकेंड पर वॉल्यूम, मतलब एक सेकेंड में कितना एटम्स पंप हो रहा है? 10 की पावर 20 एटम्स पंप हो रहा है ग्राउंड स्टेट से अपर स्टेट. ऑल्सो पर वॉल्यूम, सेंटीमीटर क्यूब का मतलब क्या है? पर वॉल्यूम. मतलब आपका जो सिस्टम है, सिस्टम का एक सेकेंड में पर सेकेंड पर वॉल्यूम में इतना एटम्स क्या हो रहा है ग्राउंड स्टेट से सेकेंड एक्साइटेड स्टेट में पंप हो रहा है. R means number of atoms pumping per unit time per unit volume. Okay, so at thermal equilibrium I can write that R minus N2 by tau 2 that should be equals to 0. It means that population at level 2 at thermal equilibrium, that should be equals to how much? Pumping rate into tau of 2. एक्चुअली जो हम बोलते हैं N2, ये पॉपुलेशन है नहीं, एक्चुअली ये पॉपुलेशन डेंसिटी है. N2 जो हम कैलकुलेट करते हैं या N1 कैलकुलेट करते हैं, दैट इज नॉट एक्चुअली पॉपुलेशन, दिस इज एक्चुअली पॉपुलेशन डेंसिटी. सो इफ आई सब्स्टिट्यूट दैट R वैल्यू कितना है आपका? 10 की पावर 20 है. एंड टाउ 2 कितना है आपके पास? 20 इंटू 10 की पावर माइनस 9 सेकेंड. 10 की पावर माइनस 9 सेकेंड. Okay, and also here I think I made a mistake. Here आपका जो dimension given है atoms per centimeter cube, also there is a second is there. There is second also there. ठीक है ना? तो जो N2 कितना मिलेगा आपको? If you solve it, this 20 from here, 20 से हम इसको क्या लिख सकते हैं? -8 लिख सकते हैं. Then you will get 2 into 20 minus 8, that will be how much? That will be 10 की power 12. And that dimension will be what? It will be atoms per centimeter cube. Atoms per centimeter cube. So this will be the population density of level 2 at thermal equilibrium. Tell me if you have any doubt.
So please WP और R में relationship
Okay,
थोड़ा
I'm
सा.
telling you. R मतलब क्या है एक्चुअली? R मतलब क्या है आपका? जो हम WPNG लिख रहे हैं ना, WPNG या WPN, WPN equals to R. That's it.
Okay sir.
तो जो हम N2 या N1 लिखते हैं, this is not actually number of atoms. This is what? This is the number of atoms per unit volume. जो हम population actually बोलते हैं. This is not actually exactly population. This is population density. Okay, so number of atoms per unit volume at level 2 at thermal equilibrium, that will be how much? 2 into 10 to the power 12 atoms per centimeter cube. So we can see from here, it represents that atomic density, atoms per centimeter cube. Okay. Now similarly, total rate of change of population of level on dN1 by dt, that will be how much? So this rate decay from 2 to 1, it will increase that population at what rate? So to increase, since this is increasing that population, I'll use plus sign. And at what rate? That will be N2 by tau of 2-1. But this decay from 1 to 0, it will decrease that population. I'll use minus sign. At what rate? That will be population of level on divided by lifetime of this decay. So this will be N1 by tau of on 0. At thermal equilibrium, this should be equal to 0. Because you have to calculate it. Yes.
Here, one state.
Sorry. Do you have any doubt? Please ask me. I am not clear actually.
Hello.
Yes, your voice is not clear.
Hello. Now it is clear.
Yes.
Okay. Sir, I am saying that we are having three levels: 0,
Exactly.
1, and 2.
Yes.
So can I say that level 1 is metastable state?
Exactly.
Okay, sir.
From here you can see lifetime. Lifetime of this decay is how much? Microsecond. This is in nanosecond. So whatever atom is pumping, it will stay long time here. You can understand that dimension, right? Micrometer और nanosecond में क्या फर्क है?
Yes, sir. Yes, sir. Yes, sir.
Okay. Now can you please tell me how much will be that population N1? So N1 should be how much? That should be tau of on 0 divided by tau of 2 on into N2, right? And we have obtained that value of N2, right? Just I'll substitute that. So I'll substitute that N2 was how much? 2 into 10 की power 12 tau on 0 कितना है? On microsecond. So I'll write on into 10 की power minus 6 second. Then tau 2 on है, that is how much? 20 nanoseconds. So I'll use 20 into 10 की power minus 9 second. So this 10 will cancel on power, it will be minus 8. And this 2 will be cancelled. Okay. So then this minus 8 will go to upper side, it will make plus 8. Minus 6 plus 8, it will be plus 2. And you have 10 to the power 12 already. You have to add plus 2. It means it will be 10 to the power 14 atoms per centimeter cube. So this will be the population density of level on at thermal equilibrium. Tell me if you have any doubt. Yes, you have a doubt? Okay, last part. Actually, I left. Actually, I forgot to discuss that part. And this is the last part of laser. And this is part of Ruby laser. And that topic is minimum power required to achieve population inversion in a Ruby laser. Okay. This is the part of Ruby laser. Okay. I forgot to discuss this part. Okay. So again, you have a three-level system. Okay. Let us denote that system. You have a ground state. Okay. Ground state sorry, 0, or you can mention, we can write this symbol. Then you have a upper state U and metastable state M. Okay. Let us assume that population of, sorry, this energy level is having energy E0 and upper state ka mano energy E. And number of population of this ground state, let us assume that is N0. And number of atoms here N1. And also let us assume that lifetime of this upper state is tau. Okay. Nothing is there. You have a three-level ground state, metastable state, upper state. Energy of ground state is 0. Number of atoms per unit volume N0. Upper ke liye number of atoms per unit volume, that is N1. Lifetime of this level is tau, and energy of this level is U. That much symbol I needed. And for metastable state, we don't need this symbol to discuss this topic. Okay.
Sorry, sir, I have a question.
You have a question?
Yes, sir.
Yes.
Sir, we have discussed problem and also we have the topic under the condition for at thermal equilibrium, है ना? The number of population density at thermal equilibrium we have got na in previous topic and also in the problems. And thermal equilibrium means temperature constant.
At thermal equilibrium, not only temperature constant, also population of each level is constant. I mean, you have achieved that stability condition of your system.
Okay, मैं ये पूछना चाहती हूँ कि वहाँ पे मतलब this is मतलब to achieve the population inversion, it is necessary to create the thermal equilibrium?
No, that's not necessary. But you see, to maintain that constant intensity of laser light, you have to maintain equilibrium condition. अगर equilibrium condition नहीं है आपका system में, then you will not get constant intensity from laser beam. But we need constant intensity to perform any experiment, right? So you have to achieve this thermal equilibrium as well.
Okay. और अगर thermal equilibrium नहीं है तो मतलब
You have
there
to
would
attain that thermal equilibrium. आपका
that is a condition for the laser also,
exactly.
ना? That is also a condition. Okay.
Now we are discussing this topic, and that is related to actually Ruby laser. I forgot to mention or discuss that time. Extremely sorry, but we are discussing here. Okay. So you have a topic is minimum power कितना चाहिए आपको external source से ताकि आपको population inversion आपको मिले. So I have defined just 3 levels: ground state, upper state, metastable state. Okay.
Sir,
Yes.
I have a doubt, sir. Why metastable state have no energy and number of
Yeah,
atoms?
you can denote. That's not necessary to discuss this topic. I'll use this EM and let us assume NM. Actually, what I'm saying, to discuss this topic, no need to define this parameter, but you can.
Okay.
Now let us define that pumping frequency. Nu P is your pumping frequency. Pumping frequency. Okay. So what is happening? When we apply this frequency, है ना, जो आपका photons आ रहा है, उसका
Sir,
frequency कितना है? Nu P.
sir, we're getting a background sound.
Are you everyone?
सर यस सर ऑडियो प्रॉब्लम अब सही होगी सर
अब सही हो गए? Okay, very good.
अभी आ रही है
नहीं
सर
sir,
दोबारा
अभी भी है sir.
Still is coming. Okay.
Sir,
very good.
अभी
अभी
सही होगी सर.
अभी भी आ रहा है?
No sir, no, it's okay.
No,
नो सर सही है सर
So nu P is what? This is your pumping frequency. I mean that whatever frequency you are using, it's sorry, whatever photons you are using, the frequency of this photons is how much? Nu P. Now when this photons is absorbed by these atoms sitting at ground state, it will be jump to upper state. Okay, it will be jump to upper state. And tau is the lifetime of this upper state. Okay. Now we know, or I can write n on by tau. It will be how much? What is this actually? You can mention also n on by tau. It represents number of atoms or ions. Number of atoms or ions decaying per unit time from upper level. From upper level U. Okay. Number of atoms decaying per unit time from upper level U. Okay. Now, power क्या होता है? Power P is nothing but energy per
Sir?
unit time. Yes.
So please repeat that last statement you said.
N on by tau represents number of atoms or ions decaying per unit time from upper level U.
Okay sir.
Now, what is power? We know power is nothing but what? Energy per unit time. Okay. And energy will be how much? Energy will be H nu P, because nu P is the frequency. So energy will be how much? H nu P. And in place of time, what I'll use time of upper level, tau. So what is this power is telling? This power P telling that this much of power you have to give to maintain on atoms at upper level.
Sir, pardon, sir.
Hmm?
So can you repeat last sentence what you put?
Yes. What I'm saying, power is nothing but energy per unit time. Energy will be how much? Since nu p is frequency, energy will be h nu p, right? And in place of time, I'm using lifetime of upper level, that is tau. Now h nu p by tau, this represents a power that we have to give to maintain a single atoms or ions at level u. मतलब एक एटम्स को यहाँ पे मेंटेन करने के लिए आपको इतना एनर्जी आपको बाहर से देना पड़ेगा. दैट एनर्जी विल बी हाउ मच? h nu p by tau. और ये आपको फ्रीक्वेंटली देना पड़ेगा इतना पावर, तभी एक एटम्स यहाँ पे, एटम्स और आयंस यहाँ पे आपका हमेशा मेंटेन रहेगा. तो आप बताओ, एनोन नंबर ऑफ एटम्स को अगर आप इस लेवल में मेंटेन करने के लिए आपको कितना पावर देना पड़ेगा? एक एटम्स को मेंटेन करने के लिए इतना पावर चाहिए, है ना?
10 times, sir.
Exactly.
HNP
So
better.
that power will be how much? To maintain anon atoms at level u, you need power that will be how much? N on h nu p by tau. ठीक है, इसका मतलब यह है कि इतना पावर आप दोगे तो यहाँ पे कितना नंबर ऑफ एटम्स मेंटेन होगा? कितना एटम्स रहेगा यहाँ पे हमेशा?
N1.
एग्जैक्टली N1. अब सपोज मान लो टोटल सिस्टम में, आप सपोज मान लो टोटल जो एटम्स है दैट विल बी n. सपोज मान लो आपका सिस्टम में टोटल n नंबर ऑफ, सिंस हम बात कर रहे हैं किसके बात कर रहे हैं? रूबी लेजर का. तो सपोज मान लो आपका टोटल जो है n नंबर ऑफ क्रोमियम 3+ आयन है. कितना? n नंबर ऑफ क्रोमियम 3+ आयन है.
यहाँ पे हम N1 अब नंबर डेंसिटी लेंगे, पॉपुलेशन
ऑफ
डेंसिटी.
कोर्स जहां पे भी हम लिखते हैं ना n, दैट इज नो लॉन्गर सिंपली पॉपुलेशन. हम ये क्या है एक्चुअली? दिस इज नथिंग बट पॉपुलेशन डेंसिटी. जो हम लिखते हैं ना n, दैट इज नो लॉन्गर दैट नंबर ऑफ एटम्स. दिस इज एक्चुअली नंबर ऑफ एटम्स पर यूनिट वॉल्यूम. ओके, सो इतना पावर आपको चाहिए, है ना? अब इस टाइम क्या होगा? आपका एनो नंबर ऑफ एटम्स यहाँ पे स्टे करेगा, मतलब यहाँ पे आपका मेंटेन रहेगा हमेशा. अब यहाँ पे जो एटम्स होता है वो इमीडिएटली जंप होकर कहाँ पे आता है? जो एटम्स यहाँ पे मेंटेन होता है, एनो नंबर ऑफ एटम्स जो आपका यहाँ पे मेंटेन है दैट विल इमीडिएटली कम टू मेटास्टेबल स्टेट. क्योंकि यहाँ पे तो एटम्स स्टे नहीं कर सकते, इसका लाइफ टाइम काफी स्मॉल होते हैं. टोटल आपका कितना आयंस है? दैट इज n, है ना? टोटल सिस्टम में नहीं. तो एनोन को मेंटेन करने के लिए आपको कितना चाहिए? इतना पावर चाहिए. और वो जो एनोन है दैट विल इमीडिएटली कम टू वेयर? मेटास्टेबल स्टेट. तो एनोन एटलीस्ट कितना हो ताकि पॉपुलेशन इन्वर्जन अचीव हो बिटवीन मेटास्टेबल स्टेट एंड ग्राउंड स्टेट? एटलीस्ट आपको आधा तो पंप करना ही पड़ेगा. सपोज मान लो टोटल आपका सिस्टम में कितना एटम्स है? n है. तो एटलीस्ट आपको आधा एटम्स को तो पंप करना ही पड़ेगा ग्राउंड स्टेट से अपर स्टेट में, ताकि ये सारे यहाँ पे आ जाए. उसके बाद ही आपका पॉपुलेशन इन्वर्जन पॉसिबल है. उसके बाद तो मिनिमम पावर जो रिक्वायर्ड है पंप जो पॉपुलेशन इन्वर्जन अचीव करने के लिए, उसके लिए n1 कितना होना पड़ेगा? दैट शुड बी टोटल नंबर ऑफ एटम्स डिवाइड बाय 2. तो आपको आधा एटलीस्ट सेंड करना ही पड़ेगा अपर स्टेट में, ताकि ये सारे यहाँ पे आ जाए. देन यू विल गेट पॉपुलेशन इन्वर्जन बिटवीन मेटास्टेबल स्टेट एंड ग्राउंड स्टेट. So at least you need this much of power, n by 2 h nu p by tau. This much power at least we need to get population inversion between metastable state and ground state. And this, I must say, this is really important for your exam. Okay. So this is all about your laser. So tell me if you have any more question.
Sir, can you please explain why we write n by 2?
Yes. You have how many atoms are there in the system? Atoms are ions.
N
टोटल
atoms.
n, ठीक है ना? टोटल आपका n है सिस्टम में, तो यहाँ पे तो आपका डायरेक्टली कहीं जा नहीं सकते एटम्स, किसके थ्रू जाएंगे? इसके थ्रू।
Yes, sir.
आपको पंप करना पड़ेगा एटम्स कहाँ से? ग्राउंड स्टेट से यहाँ। और आपको पंप फ्रीक्वेंसी जो आप पावर दे रहे हो ये आपको फ्रीक्वेंटली देना पड़ेगा, क्योंकि आपको यहाँ पे एटम्स को
पंप करना।
कॉन्स्टेंटली आपको मेंटेन करना पड़ेगा ना एटम्स, नहीं तो वो गिर जाएगा ना, क्योंकि इसका एक लाइफ टाइम है, तो उसको आपको मेंटेन करना पड़ेगा, है ना? अब ये एटम तो यहाँ नहीं रह सकता है, जो आप यहाँ पे मेंटेन कर रहे हो एटम, दैट विल इमीडिएटली कम टू हियर।
यस सर।
तो आप सपोज मान लो n/2 एटम्स को यहाँ पे पंप कर दिया, इट मींस n/2 कहाँ पे चला जाएगा? इट विल इमीडिएटली कम टू हियर। तो यहाँ पे आपका पॉपुलेशन कितना हो गया? अब n/2 जो आपका टोटल पॉपुलेशन का आधा हो गया।
यस सर।
इस टाइम ग्राउंड पे कितना रहेगा?
n/2।
हाँ, उसके बाद ही आपका पॉपुलेशन इन्वर्जन ऐसे भी हो सकता है, मतलब मिनिमम आपको हाफ आपको पंप करना ही पड़ेगा, उसके बाद ही पॉपुलेशन इन्वर्जन पॉसिबल है।
सर n/2 पे तो पॉपुलेशन इन्वर्जन नहीं होगा
दैट्स व्हाट आई एम सेइंग, उसके बाद ही आपको पॉपुलेशन इन्वर्जन मिलेगा। एटलीस्ट यू हैव टू मेंटेन दिस मच पावर, इसके बाद ही आपको मिलेगा।
आफ्टर दिस पावर।
हाँ, यस,
एटलीस्ट
आपको आधा पंप करना ही पड़ेगा एटम्स को।
यस सर।
Okay, I must stop here. Okay, you have another class, right?
Thank you, sir.
Welcome.
Thank you, sir.